Hi everyone! Today we're going to discuss about arithmetic series. So the goal of this video is to define the arithmetic series and to find the nth partial sum of an arithmetic sequence. What is arithmetic series? So arithmetic series is the sum of the terms of an arithmetic sequence. So to find the nth partial sum of an arithmetic sequence, these formulas are needed. So the sum S sub n of the first n terms of an arithmetic sequence is denoted by S sub n is equals to n over 2 times the quantity of a sub 1 plus a sub n, or S sub n is equals to n over 2 times 2a sub 1 plus the quantity of n minus 1 times d, wherein S sub n means the sum of the terms, a sub 1 as the first term, a sub n as the last term, and number of terms, and d for the common difference. Consider this arithmetic sequence numbers 1 to 100. And consider also this arithmetic series numbers 1 to 100. Now try to look at this one. If we try to add first term from the last term, we will get a sum of 101. And if we add the second term and the second term from the last term, we also get the sum of 101. Same also with the third term, and so on. So since we add the first term and the last term, so we have 50 terms all in all. So we multiply it by the sum of 101. So we have 50 times 101. So we got an answer of 5,050. Do you know that Carl Gauss is a German mathematician who was able to give the sum from 1 to 100 at the fastest rate when he was a little boy? So this is how Gauss solved the problem by writing So he write 1 plus 2 plus 3 until 98 plus 99 plus 100. And he also write the reverse of the first equation, which is S is equals to 100 plus 99 plus 98 plus 3 plus 2 plus 1. Now if you add these two equations together, you get an interesting result. So we will have a result of 2S equals 101 plus 101 plus 101 plus 101, and so on. Therefore, 2S is equals to 101 times 100. So we will have an answer of 10,100. Since we want to eliminate the 2 in the S, so we will have an answer of 5,050. And then we extend this into a formula by writing a more generic series. So we'll let S sub n is equals to a sub 1 plus a sub 2 plus a sub 3 plus a sub n. So we have a first equation and the reverse of the first equation. So we will have an answer of 2s sub n is equals to the quantity of a sub 1 plus a sub n plus the quantity of a sub 1 plus a sub n plus the quantity of a sub 1 plus a sub n until the last answer. Since we are not so sure if how many terms we are actually adding, we let it to be in an n terms. Thus, 2Sn is equals to n times the quantity of a sub 1 plus a sub n. So we get the formula of S sub n is equals to n over 2 times the quantity of a sub 1 plus a sub n. So that's how we derive the first formula. Now, How about if the last term is unknown? So we know that to find the nth term, the formula for this is a sub n is equals to a sub 1 plus the quantity of n minus 1 times d. So we just simply substitute it to our first formula. So we will have s sub n is equals to n over 2 times a sub 1 plus a sub 1 plus the quantity of n minus 1 times d. So we now get or derive the second formula. So this is the formula we use if the term is unknown. So in finding the sum, there are 3 steps to remember. The first step is to identify the first term, the nth term, the term position, and the common difference. The second step is to use the formula in finding the sum of the first n terms of an arithmetic sequence. The third step is to substitute the values and calculate for the sum. For an illustrative examples, we have example number 1. Find the sum of the arithmetic sequence 13 plus 21 plus 29 plus 37 until 165. So applying the steps, we identify the a sub 1, the a sub n, the n, and the d. So we have a sub 1 is equals to 13, a sub n is equals to 165, d is equals to 8, n is the unknown. Since the term position n is unknown, solve for n first using the nth term formula. So we have a sub n is equals to a sub 1 plus the quantity of n minus 1 times d. So we substitute the values for a sub n, a sub 1, and d. Combine like terms. Then we simplify. And we now have our n, which is 20. So we use the formula for the sum of the first n terms and arithmetic sequence. So s sub n is equals to n times the quantity of a sub 1 plus a sub n. Then again, we substitute the values and simplify. And we got an answer of s sub 20 is equals to 1,780. For the second example, find the sum of the first 15 terms of the arithmetic sequence 4, 10, 16, 22. So applying the steps, identify the a sub 1, the n, and d of the given arithmetic sequence. So we have a sub 1 is equals to 4, d is equals to 6, n is equals to 15. Since the known values are a1, n, and d appear in the second formula for s sub n, we use it. So we use the formula for s sub n. So we substitute the values and we simplify. That's why we got an answer of s sub 15 is equals to 690. For the third example, every week, Mr. Santos increases his profit from selling cell phones by 250 pesos. So his profit during the first week is 2,750 pesos. How much will his total profit on the 12th week? So applying the steps, we identify the a sub 1, the n, and d of the given arithmetic sequence. So for a sub 1, we have 2,750, d is equals to 250, and n is equals to 12. Since the known values are a sub 1, n, and d, we use the following formula. So the formula for this one is s sub n is equals to n over 2 times 2a sub 1 plus the quantity of n minus 1 times d. So we substitute the values and then simplify. So we got an answer of S sub 15 is equals to 49,500. Thank you for watching. Again, this is Anabelle Buca.